Welcome to Pre-Calculus. In this video, I'd like to talk about the definition of a function and look at a few examples. So a function is a relation between a set of input values called the domain and a set of output values called the range, so that each input value leads to exactly one output value. I highlighted four important parts of this definition. First, we have a set of input values. Often those are x values. That's called the domain. Second, we have a set of output values, often referred to as y values. That is the range. And a function is a relation that matches up these x values with y values in such a way that each input value leads to exactly one output value. That last part is the most important part of our definition of a function. And it is the phrase that we'll keep coming back to as we look at our examples. So let's look at a few examples, and you'll notice that these relations are written in different forms. Relations might be listed as a table, they might be a list of ordered pairs or coordinate points, they might be equations, they might be shown on a graph. These are just a few ways to show relations. For each one, I want to ask, is this a function? And I want to give the domain and range. So looking at our first table of points, we have some x values paired with some y values. The x value 1 goes to 2, 2 goes to 3, 3 goes to 4, 4 goes to 5, and so on. Every x value is matched with only one and exactly one y value. So this is a function. The domain is the x values that are listed. We would say the domain is the numbers 1, 2, 3, and 4. Let's write those as discrete points. And the range is the y values. We would say that our range is the numbers 2, 3, 4, and 5. Let's go on to our next example. Here's a list of ordered pairs. And once again, we have some x values and y values. 1 is matched with 2, 2 is matched with -3, 3 is matched with 4, and 2 is matched with 4. This relation is not a function, and the reason is the x value of 2 is matched with two different y values. In this pair, it matches with -3, and in this pair, it matches with 4. If someone were to give you an input of 2 for this relation and ask for the output, you would not know which answer to give. You would say, well, the output might be -3, but it also might be +4. Because of this, this is not a function. We could still give a domain and range here for this relation, but I'm going to move on from this example. Our third example is an equation, y equals x squared minus 3. And we could represent this or think about this equation maybe by plugging in some x values and getting some y values. If you want another way to look at this, we could say let's plug in the x value of 1 and we would get an output of -2 for y. We could do this again, plug in the x value of 0 and we would get an output of -3 and so on. You could also draw a sketch of this equation. The sketch of this equation looks like a parabola. It is a quadratic function, and this is roughly the shape. Based on the table of points or on the sketch, it does appear that this equation is a function. Every x value matches with exactly one y value. If you plug a number in for x into this equation, it will give you exactly one number as an output for y. Another way to test a graph of a relation as to whether or not it's a function is using the vertical line test. The vertical line test is mentioned here. A relation is a function if and only if no vertical line intersects its graph more than once. The idea of this test is every vertical line I draw through a graph represents a specific x value. So if I draw vertical lines through my graph and they only cross the graph in one point, that means that that x value is paired with only one y value on that graph, and that is a function. So this relation is indeed a function. It passes the vertical line test. The domain of this relation is actually all real numbers. We're going to write that in interval notation, thinking of the number line from negative infinity to positive infinity. You could plug any x value into this equation and you could get an output value for y. The range of this equation, however, is limited, and we can see this from the graph of the function. I did not label this point, but this is the point 0, -3. We'll get some tools later on in this course to be able to find that intercept. So the range is from -3 to positive infinity. The lowest the y value could be is -3, and then it goes upward from there, reaching to positive infinity. Finally, we have one more example here, and I'm going to use the vertical line test to test this example. Is this a function? Well, I would say no, this is not a function. If I draw a vertical line through this graph, it intersects the graph in more than one point. That means that this single x value of +3 is matching with two different y values on the graph. And because of that, this is not a function. I will still take some time to give the domain and range of this relation. So we have domain and we have range. The domain is the x values, and as I look at this graph, it looks like the x values from 0 to 4 are represented on the graph. This is using the horizontal axis. The range is the y values, using the vertical axis as our numbers. And so as I look at this, again, it looks like the y values from 0 to 4 are represented on this graph. So again, in this video, we talked about the definition of a function. We tested the definition with a variety of examples, and we learned about using the vertical line test as a shortcut to test the graph of a relation.